Hi there, I'm Joe Newberg, President of the Geological Society of Minnesota. Welcome to our second GSM lecture for the fall 2021 season. Thanks for being part of a tradition that goes back 83 years to 1938. This lecture's topic is Earthquake Science and Impacts of a Major Earthquake on the New Madrid Seismic Zone by Larry Pierce. More about Larry later. Tonight's format. These announcements, then Randy's 1 hour lecture. I'm sorry. Larry's 1 hour lecture, followed by Q&A. All participants other than the host, the presenter, and the moderators are muted. For most lectures, including this one, Randy Strobel is the host, and he, Dave Wilhelm, and I are moderators. As always, thanks, Randy, for setting up these Zoom webinars. The Zoom platform offers a number of means of interaction that we use. We would like to handle most questions at the end. To enter a question at any time during the lecture, click the Q&A icon and type in your question. You need not wait until the end. For those few persons joining by phone, we will unmute you at the end in case you have any questions. We might also unmute other questioners if they need to clarify their question. If you have a quick question for which you would like an immediate answer, click the raise hand icon and enter the question. For these, the moderators will use their judgment about interrupting the presenter during their presentation. Also use raise hand to report any technical issue you might experience. There's also a chat option that allows you to type a message for all participants to see. Feel free to use that before the lecture starts and to greet others. Be sure to use the all panelists attendees option. I'll mention 3 other ways we use chat shortly. Like most GSM webinars, this one will be recorded. The full lecture schedule is on our website, gsmn.org. Thanks to Steve Erickson for arranging another outstanding slate of topics and presenters. As with our live lectures, this lecture is free and open to the public, not just GSM members. If you're not a GSM member, please open the chat box and type non-member and your city, state, province, or country. Also mention how you found out about us. We like to see how many non-members attend, so we may see how well our information reaches the general public. So please do that for us. Thank you. Of course, we'd love for you to consider joining our organization. Membership information and forms are on our website. Membership dues are the primary method by which we fund these lectures and our other programs. Also, we can count the number of devices that tune in, but not the number of people watching from each. So we get a better count of those participating. If you are watching with at least one other person, type 2 persons or whatever your number is in the chat box. Thank you. Continuing education credits. These lectures are eligible for 1 hour of CE credit. If that is something you can use chat to request a form, include your name and email address. If you don't want everyone to see this information, there is a chat option that allows only the moderators to see what you type. Following the meeting, we'll fill out a form, sign it, and email it to you. Are there any other announcements at this time? Use raise hand if you do. Not seeing any. Tonight's speaker, Larry Boot Pierce, is a geologist with the Missouri Geological Survey. I should say was. He received his bachelor's degree from Southeast Missouri State University, SEMO, and master's from Missouri State University, MSU. In 1992, he began with the Missouri Geologic Survey's Environmental Geology section, working on groundwater hydrology and geologic hazards assessment issues. In his current role as Chief of Geologic Resource Section, he oversees geological mapping, industrial and metallic mineral resource assessment, historic data preservation, and geological hazards assessment. His research includes assessment of critical mineral resources, earthquake hazards in the new Madrid Seismic Zone, and studying the relationships between rock type and glade ecological communities. Boot also serves on the Missouri Natural Areas Committee. In addition to his Missouri Geological Survey duties, he's a geology instructor for the East Central College in Union, Missouri, and owns Rainwater Fly Fishing School and Guide Service. And as a footnote, my understanding, Boot, is that you just retired a couple days ago, and this is all in the past.
It is actually. I retired last day at the office was the 24th of September, and I started the first day of October with a consulting company in Santa Fe. So yeah, life changed pretty drastically in the last week or two.
Being one who's retired, I fully understand.
So let me see. Oh, let me see if I can go ahead and share my screen.
Go for it.
All right.
Joe, you have to unshare first.
Yep.
How's that? I think that should be it. Can everybody see that?
Yep, looks perfect.
Okay. So again, my name is Larry Pierce. I go by Boot. I have all my life. Up until just recently, I did earthquake research, talking to earthquakes of the Madrid Seismic Zone. So tonight, I'm going to talk a little bit about the earthquake science of the Madrid Seismic Zone, a little bit on the different impacts of a major earthquake in the Madrid Seismic Zone, and then a little bit about kind of earthquake prediction and the future of earthquake research in the Madrid Seismic Zone. A little bit of kind of the direct and indirect impacts, the cost, and then like I said, the future of earthquake science, both predictions and warnings. The Madrid Seismic Zone is located in southeast Missouri, starts in northeast Arkansas, extends through southeast Missouri, western Kentucky, western Tennessee. It is essentially a failed rift zone from about starting with the breakup of Rodinia about 650 million years ago, 700 million years ago. There was crustal thinning, and as that plate began to try to break up, it tried to stretch the North American continent in two. It obviously did not succeed. However, it did succeed with some crustal thinning. If we go to the next slide, you can see down in the central part, that kind of that red or that purple there, that's the Reelfoot rift. Again, you can see it goes from Arkansas up through Missouri into Illinois, parts of Kentucky, Tennessee, Indiana, and just a little bit of the very northwest corner of Mississippi. Again, about 650 million years ago, as Rodinia was breaking up, it began to try to pull the continent apart. It rifted, but it didn't succeed in completely breaking apart. Then you've got this settling there. You've got these sediments. You've got these thick Paleozoic sediments down in there, and then those are deep. And then you've got the thick sediment of the Mississippi embayment sitting right on top of that. Currently, it's buried under thick alluvium. The stress buildup now is more tensional rather than the rifting. What you're essentially having is you're having the plate getting pushed westward from the spreading center in the middle of the Atlantic, so it's pushing the entire plate towards the west. I always try to tell my students that the easiest way to think of this is think of a giant broken slab of concrete. You've got this big slab of concrete, it gets smashed or cracked and busted in the middle, and then you turn around and start pushing it from one edge. You're going to have stuff that gets shifted around. There is some volcanics that are associated with it. There is some plutons that we have down in here coming up. Excuse me, some of this basalts down in here coming up as well. The New Madrid Seismic Zone also extends a little bit further up into Illinois and Indiana. The Wabash Valley Seismic Zone and the South Central Illinois Seismic Zone are kind of that northern extent of this, of the Reelfoot Rift. From geologic studies, we've been able to find out certain information about the New Madrid Seismic Zone. I'll go a little bit more in detail about this later. We know that this New Madrid Seismic Zone has been active at least for the last few thousand years. There's some evidence dating back to 2300 BC. Obviously, we know it dates farther back because of the rifting, but this is what we can see in some of the paleoseismic features. Unfortunately, the New Madrid Seismic Zone is buried beneath those deep sediments. So to go out and actually see a fault or see movement is very difficult. So the paleoseismic features are what the scientists primarily study. The average life or the average time span between events seems to be about 500 years, at least for about the last 1200 years. About every 500 years, there's a seismic event. Looking at the paleoseismic features, the prehistoric events, that event 1450, 900 AD, appear to be similar in size to the 1811 and 1812 earthquakes, which occurred. Those ranged from about 7.5 to 7 to 7.5 as the largest of them. And the other thing that looking at the paleoseismic features is that it appears that even historically, the New Madrid seismic events have always been a sequence of earthquakes, usually multiple very large shocks, similar to the 1811 and 1812 sequence. If we look, this is a kind of a timeline from the USGS, and it shows the earthquakes that occurred throughout the first 2 months, starting in December of 1811, going through February of 1812. You can see the largest one the first one occurs on December 16th, 1811. But pretty dramatically through there, just in that first week, there's several that are over size 6. Dozens and dozens of smaller shocks until we have another 7.3 5 weeks later. Continue on. You have another 7.5 that is in February, and that process continues on. If you read some of the historical documentation, some of the people that were in the area talked about how the ground shook for almost a year. So the aftershocks were quite dramatic. Obviously, they weren't 7.5s, but a lot of those 5s and 4s that just kind of kept that area just shaking for quite some time afterwards. So I'll talk a little bit about some of the impacts that an earthquake in the New Madrid Seismic Zone would occur. First and foremost, these are the direct impacts, what to expect. And this is primarily in the central Missouri, the central seismic zone area. Direct impacts from shaking, that's definitely something that can be expected. Fires are something that are an impact that we often see. The left-hand side of your screen is the 1906 San Francisco earthquake. probably the largest loss of life from an earthquake in the United States. Most of that was due to fire and not necessarily the earthquake itself. 1906 was kind of that perfect storm in San Francisco. They were building wooden homes just about as fast as you can imagine. You've got a new, great, wonderful technology called gas lamps and gas heating. However, you didn't necessarily have the engineering that we do now with the shut-off valves and stuff like that. So you start shaking everything, start breaking all those gas lines. You're essentially feeding the fire. And at the same time, most of the water passed through a clay tile pipe. And so you start shaking them and everything, and your water lines begin to break. And it's kind of that perfect storm for a fire. No water to fight it with. I cannot remember the exact location on the photo on your right. I do remember seeing a lot of fires when the tsunami hit in Japan a few years ago. So fires are definitely something that are kind of an aftermath of that. Next thing that some of the direct impacts due to compression, you see a lot of just construction damage, that type of stuff, compression here, popping these roads up. This is in California. This is from NOAA. And liquefaction. Liquefaction is a big thing that's expected to happen in Southeast Missouri. We have very shallow water tables. We have soft sediments. So that's something that occurs. I'll go a little bit more in detail about this.
Hey,
So
Booth,
here,
Booth,
yes.
This is Dave Wilhelm. I'd like to interrupt real quick. Two things. There seems the bottom of your slide seemed to be cut off a little bit. I'm not sure you can do much about it, but we can pretty much read what's there. And secondly, there seems to be some kind of a popping noise in the background. I don't know. And I think everybody else is muted, so I don't know where that's coming from.
Okay. I guess let me try something. Try to figure out how to. I put it on full screen. Does that help with the bottom of the slide?
You can't tell because that slide doesn't have anything at the bottom.
Oh,
And we're only losing a little bit, so we can pretty much read it.
okay.
And then the other thing is that noise. I don't know if you can do anything about that, but.
So I guess let me know when the noise occurs, and I can
I'm
see if
hearing
it's
it kind of continuously.
continuously.
Yeah, it's a little kind of a popping noise. Are you hearing it, Joe?
Yes,
I wondering if it could.
I think it's, yeah,
Can you hear me now?
yes,
Can you still hear the popping?
no.
Okay, it may have been my earplugs because I was using a microphone on my earplug. So if you can still hear me, I'll just continue on like this. Is that okay?
Yes, sounds good.
Okay. So where were we? Okay, so here liquefaction is a kind of a phenomenon that occurs when you have sands beneath a confining layer of clay or silt. And when you begin shaking that, the moisture of the water starts moving upwards, and you end up with what we call like a sand blow. You can see on the left-hand side here, sand volcanoes, sometimes they'll call them. And the right-hand side, the upper picture is actually a picture of the city of New Madrid, Missouri. So you can see kind of the amount of liquefaction that occurs in some of these areas as the sand gets pushed up towards the surface. And seismologists have actually gone through and cut through some of these sand blows and been able to find that they not only occur, they occur multiple times from different earthquakes. So on the lower right-hand side, you can see the sand blow that occurred during the 900 AD earthquake. You have it pushes the sand towards the surface. You have a developmental time for that A horizon to form. And then we can see the second sand blow from that 1811 and 1812 earthquake as well. So this is kind of a process of liquefaction. Here is a slide from Christchurch, New Zealand, where you can see there what looks like is underwater is primarily just sand that's blown up, that's pushed up through the subsurface to the surface. And as that sand pushes up, the whole area begins to kind of subside. And in doing so, then flooding comes in later, kind of on top of that. Lateral spread or earth flow is another phenomenon that we see with or expect in the Madrid Seismic Zone. You've got these again, that sand layer with the confining layer that's sitting on top of it. You start shaking it. When you have a stream of some sort off to one side, it basically starts kind of shaking and migrating towards that. And you end up with these lateral spreads. Couple pictures coming up. I think this first one is from, okay, this is in 1964, this Prince William earthquake. You can see these large fractures, and as this kind of drops down, this lateral spreading. This was about 100 miles from the epicenter. This one is actually in Anchorage, again, about 100 miles, but you can see some of that. As that sediment moves out, it kind of starts migrating down slope. This one is from the Nisqually earthquake in Washington just a few years ago. And you can see as that you've got this sediment starts migrating down slope. And so here's one that's not quite as dramatic, but we do see that, it does create damage just as you have a little bit of that stuff starts migrating down slope. Landslides are another thing that impact from earthquakes. This green area right through here is Reelfoot Lake. This is an area of subsidence. This bright orange or kind of pinkish orange area right here is an area of uplift during the 1811 and 1812 earthquakes. And you can see all along what's called the Chickasaw Bluffs right here. You can see all these landslides that occurred because of the 1811, 1812 earthquakes. Missouri's gone through and done this. The Chickasaw Bluffs are on the Tennessee side, Kentucky, Tennessee side. Missouri's gone through and did some mapping, and we found very similar landslides along the Ozark Escarpment and Crowley's Ridge on the Missouri side as well. One of the things that we have a lot more information from Kentucky and Tennessee during this time period, because it was a little bit more densely populated during 1811 and 1812 than the Missouri side. And so some of the other impacts that are expected from a New Madrid Seismic Zone earthquake, and these are what I would call indirect impacts. So these are interruptions of services or destruction of infrastructure. So everything that we've kind of talked about so far has kind of been a natural feature. This stuff like this, like interruption of transportation, bridge failures. The one on the left is probably one of that most all of us have seen. That's from San Francisco. The other one on the right is the Cooper River in Alaska. So these are, again, indirect impacts that impact everybody around, even if the earthquake doesn't necessarily you don't have the landslides or the liquefaction, but you do get impacted in other ways. Flooding is another thing that is an issue that most of the time the landslides in rugged areas can create flooding issues. This is from Professor Chin at Missouri Science and Technology. This was a 2008 presentation he had give. This is, and I cannot remember the name of the river in China. I do have to apologize, but this is a May 2006 photograph. You can see the bridge going over the river there. You can see the community on the lower side of the river. You can see some of the community and some farmlands. On the upper side of the river, earthquake occurred May 12, 2008. So that other picture was taken a couple years before. This is 3 days after the earthquake, May 15, 2008. A landslide off to the right-hand side, downriver. Water begins to back up. Behind there, that's May 15th. You go a few more days later, and essentially your bridge is underwater. Your entire towns have been submerged. Now this is kind of a dual flood, because what's going to happen is this is a non-engineered dam, really. So you have this landslide that comes down and blocks the river. The river still finds a way as the water backs up, finds a way over it. Eventually that dam's going to break. And so then you have kind of this slow flooding up above it. And now after it breaks, you're going to end up with a flash flood going down below it as that landslide blockage actually gets moved out of the way. Railroads are something that are expected to be impacted along the Missouri seismic, or excuse me, the New Madrid Seismic Zone. Right now, over the Mississippi and the Ohio rivers in the New Madrid Seismic Zone, there are 25 freight bridges which cross the river. There, I believe, are 16 passenger vehicle bridges, and there's 25 of these freight bridges that cross over the river. So along the river, the Mississippi River is definitely, and the Ohio River is definitely a major north-south corridor for railroad usage. Again, we've got those 35 bridges that cross over the river. If you look at the total usage of the river for barge traffic, this is a little bit of an older slide. I believe it's about 20%, 15 to 20% more now. But in 2013, there was over 300 million tons a year of materials that went up and down the river via barge traffic. So you can imagine what the impact or what the interruption to shipping would be if you had 1, 2, or even more of those bridges that would happen to fail. Most of the passenger vehicle bridges have been retrofitted to try to withstand a larger earthquakes. Not all of the older railroad bridges have. A lot of those were built in the early 20th century, so they are not necessarily up to the same codes that the passenger bridges are. Crude oil pipelines or fuel and energy. Out of the Gulf Coast, there are 6 primary fuel lines, refined gas fuel oil lines that feed up to the northeast part of the country. And of those 6, 3 of those run through the New Madrid Seismic Zone. So as you can imagine, while it may not be a direct impact, what would the impact be if 3 of those pipelines got reduced, or the amount of fuel moving through that, so that only the northeast was only getting about half of its fuel oil that it was expecting. If that occurred in the wintertime, that could be pretty devastating to parts of the country. Power transmission and power interruptions. Southeast Missouri has several major coal fire power plants. Even if these fire plants do survive, the railroad issues with potential railroads, how do they get their coal deliveries in? And then you've got the river barges, as well as communication power lines. These high tension lines, you start shaking those obviously have to be considered. Communication interruptions, cell towers, microwave towers, underground fiber optic cables. Most of us are all kind of familiar with that. Many of these run through the Southeast Missouri. A lot of the reasons that it does, just the same reason for the pipelines. It's flat, it's easy to dig, and it's easy to bury these this infrastructure through there. So communication interruptions are definitely something that is a kind of an indirect impact from New Madrid Seismic Zone. Up until recently, and they have kind of retrofitted the bridges, but most of the fiber optic lines that crossed from the Midwest went up to St. Louis and crossed a single bridge in St. Louis. And it's a bridge called the Eads Bridge, and it was actually built in 1874. Obviously, it has been retrofitted, and they have began to diversify some of the fiber optic data lines and routes since then. But this was about 15 years ago that all those basically ran across the same bridge that was over a century old. Water supply and water resources. This is something that is from the state of Missouri's aspect is very much on their mind, because Southeast Missouri has over 500 public water supply districts. Just kind of an example, Southern California gets 70% of their water via 4 aqueducts. All 4 of those aqueducts cross the San Andreas Fault. So water resources in a seismic zone are definitely something that have to be taken into consideration and expected to be impacted as well. And with 500 public water supply systems, that definitely is something that has to be considered. Some other lesser thought of impacts, irrigation ditches. You start shifting soft sediments, liquefaction, stuff like that. You have irrigation ditches begin to get busted. Southeast Missouri, Northeast Arkansas are major crop producing portions of our country. Sanitary sewer lines, liquefaction and movement shaking plays an impact on those. I listened to a speaker one time from Christchurch, New Zealand, and talked about all the liquefaction and that they had and the settling, and they had very similar to Memphis and St. Louis areas. They had quite a bit clay tile pipe, and in such, they primarily most of it had to break out. They had to replace pretty much all of their sanitary sewers in those parts of Christchurch because of the clay tile that had busted up. And then there's other things to think about. One of the things that not necessarily on everybody's mind, but with new farming techniques, we have a tendency to confine animals to a much smaller area. We confine them to a single location. So something as simple as a single power outage or the collapse of a roof can often lead to a major issue with something like this. This is an example where you have a pretty immediate crisis, but you have to be careful because you can't just turn around and bury these things, because then you can end up with the long-term groundwater issue. So kind of these dead animals does seem to be something that needs to be considered during an earthquake. So if we look kind of what to expect kind of in the Ozarks and beyond, this is a little bit of an older map. This is from the USGS, and this is their modified Mercalli intensity, and you can see primarily the area of impact is going to be right along the Mississippi and the Ohio floodplains, with Southeast Missouri, Northeast Arkansas, Western Tennessee, and Kentucky bearing the brunt of the impact. However, damage is expected to kind of migrate up these river valleys. When we look at this modified Mercalli, it's quite interesting, since the central part of the continent has a much more competent bedrock. When we compare earthquakes, we compare the 1906 San Francisco earthquake and the 1811 earthquake. You can see that the area that's actually felt, the Mercalli intensity that's actually felt, is much broader in the in the Midwest. I don't know that I necessarily agree that there's going to be a 5 on the Mercalli intensity all the way up into Minnesota and Wisconsin. That's probably a little bit of an exaggeration. They're estimating this on an 8.1. When we look at the New Madrid seismic earthquakes from 1811, 1812, they think there were probably closer to a 7.5. However, we do know that from historical documentation, 1811 and 1812, they did feel it along the East Coast and further north. So it's probably be felt, but I'm not sure about their Mercalli damage that they actually talk about. And when we look at or compare California to Missouri, and the kind of the break off of destruction over distance. If you compare an earthquake in California and Missouri, on the y-axis here we have intensity. This is the modified Mercalli, and on the x-axis down here we have kilometers away from the epicenter. You can see that both Missouri and California begin kind of the energy level and the intensity begins to kind of dissipate, kind of the same at first for that first 100 kilometers. However, California is a little bit more linear, and it breaks out so that by 200 kilometers, you're down to almost a 4 on the Mercalli intensity, where at 200 kilometers, you're still at 6, almost 6.5 up there. So there's definitely a breakdown, the breakdown curve of energy and how far it transmits and essentially shaking is much greater in the mid-continent than it is along California. And these two maps here, it kind of give you a comparison. This is a 4.1 earthquake near Blytheville, Arkansas, and these map scales are exactly the same. And this is a 4.1 near Paso Robles in California. So these maps are the same scale, and you can kind of get an idea on how far away it's being felt. And this is a relatively small 4.1 magnitude earthquake. So what's the cost to recover? New Madrid, an earthquake in New Madrid, the 2004 HAZUS report basically looked at a 7.7 magnitude earthquake occurring in the New Madrid seismic zone. Now, a little bit about this information. I believe that this report looked at an earthquake of 7.7 scale to occur relatively, it's on the southern extent of the New Madrid seismic zone near Memphis. So it kind of went through and gave an estimate for the 8 states kind of in the area. And if you look, the total cost down there comes out to be about $269 billion. That's talking about infrastructure, schools, stuff like that. Just to give you a little bit of scale, Hurricane Sandy was the cost estimate for it was $64 billion. Katrina was about $106 billion. And the most recent hurricane that hit Houston, when it came in, estimated costs were about $190 billion. So the cost estimates for a major earthquake in the New Madrid seismic zone are pretty high. Another thing that kind of is interesting about the New Madrid seismic zone, if you look at it, it falls smack dab in the middle of 4 distinct FEMA regions which cover the area. So you've got Missouri in region 7, you've got Illinois and Indiana in region 5, you've got Kentucky, Tennessee, and Mississippi in region 6, and you've got Arkansas in region 4. So, or excuse me, yeah, region 6 and then region 4. Had those last two backwards. So that's definitely something in this area. It does not help with recovery. Obviously, they're going to do everything they can to communicate, but when you've got 4 FEMA regions trying to communicate, it can be rather difficult sometimes. Another thing that plays a big role in the cost is just public perception. What's the media saying? Will businesses come back and reinvest? We all know that if media if the media reports a shortage on something, then there's pretty much instant speculation and everything, prices go up. We've all saw that just most recently with the price and supply of toilet paper during COVID. However, you can look back at the 1993 floods in Missouri, the Katrina flooding from Hurricane Katrina in the French Quarters. How long will it take to recover? When USGS and FEMA have done some research, and they estimated that it took almost a decade from after the 1998 and 1994 earthquakes in California. California is much more prepared than Missouri, so the recovery time for an earthquake in Missouri along the Madrid Seismic Zone is expected to be quite substantial. And then the other thing, again, we go back with public perception. Will businesses come? Will tourists come? Think about Katrina in New Orleans. Most of us would never have thought about going to New Orleans for vacation a month after Katrina. However, the French Quarters was never flooded. The French Quarters was completely operable during right after Katrina. It was other parts of the city that were actually flooded. So a lot of it is public perception, and will people go back to the area? I remember in 1993, I actually went to visit some friends in Maine during the major flooding along the Missouri and Mississippi River here in Missouri and Illinois. And I had my cousins actually ask me, how was I doing? How was I handling the flood? And they didn't realize the media had played it up to the point that the outside of Missouri and the kind of the Midwest area, everybody thought the entire state of Missouri was underwater. So that public perception is huge when it comes to recovery. FEMA and USGS have kind of worked together, and they've produced some statistics of a natural disaster, such as an earthquake or a major hurricane. But immediately following a natural disaster, almost 40% of small businesses will not reopen. Of that, 25% of those businesses that do reopen typically will fail within the first year. So you're talking a pretty large, substantial percentage there. And of those facilities that do reopen, if they do not have a long-term contingency plan, almost 75% of those businesses will fail within 3 years. Again, average cost to a small business is about $3,000 a day. To a medium-sized business is about $23,000 a day. So the business community is definitely something that needs to kind of prepare or be ready for an earthquake in the Madrid Seismic Zone. So kind of a little bit about the future of earthquake science. Talk a little bit about probability versus predictability and early warnings. So the number one question that every scientist from the Midwest is asked, if you've ever talked about the Madrid Seismic Zone, is when's the next big one going to happen? I always put in there someday. That's the easiest way to answer that. It's about as nebulous of an answer that you can give, but unfortunately, we don't have a way of predicting the earthquakes anywhere. USGS does use probabilistic seismic hazards analysis. And what they're essentially doing is they're looking at where, when, and how big. So where will the earthquakes occur in the future? They look at when or how often they will happen, how large they'll be, and how big, how much is the ground going to shake. So after looking at 1, 2, and 3, then they put all those together, and they come up with the probability of exceeding a damaging shaking. So if we kind of go through this, where we can look at the earthquakes along the Madrid Seismic Zone and see where they're at, where they've occurred, both historically, we can see with seismographs now where they are occurring, and we can look at these where it's happening. When we can go back, researchers have gone back and started looking at the paleoseismic evidence. We can all see it's a little hard to see the table on your right-hand side, or excuse me, your left-hand side there. The red there is 1811 and 1812. As we start going back in time, looking at paleoseismic features, they've been able to kind of narrow down. They know that there was a pretty substantial earthquake about 1450. There was a pretty substantial earthquake about 900. There was another one about 200 AD. And if you look even further back, there's some of them, obviously, as you go further and further back, the evidence gets sketchier and sketchier. But we do know over the last 2,000 years, there's been 4 fairly significant earthquakes along the New Madrid Seismic Zone. And then how big? So looking at the intensity of and the damage of these former earthquakes, we can look at both the scientific evidence. We showed, here's the sand blows from 1811 and 1812. I showed you that cut or bisection of the sand blows. The other thing we can do is we can go back and start looking at historical accounts. Fuller in 1911, Pinnick in 1981, and Valencius in 2013 all go, and they go back and they have accounts of how damaging the earthquakes were. Obviously, we can't get a Richter scale or a magnitude off of that, but we can get some Mercalli intensities kind of listening to these historical accounts. So we go back to this, and again, this is looking back at 1811 and looking at the when and how big for this probabilistic. It's pretty significant that this is one of the few earthquakes where you have aftershocks that are as large as the actual initial shock. You can see and occurring 2 to 3 months later almost. So then the USGS takes all this data, the when, we know the dates, how often, where they occur, how big, the historical accounts, and they put this in to produce what they call a probabilistic seismic hazards map. So this map essentially is giving us a high hazard, low hazard for the potential for peak ground acceleration to exceed 2% in a 50-year time frame. I don't know about you all. I'm not the greatest at probabilities. Weathermen seem to be the only one that can understand that, and seismologists. You can look at it more as high hazard, low hazard. So what it really boils down to in my discussions with USGS is when you're looking at the potential for an earthquake along the New Madrid Seismic Zone, there's a 40% chance of a magnitude 6.0 or larger in any 50-year time span. For a magnitude 7.0 or larger, there's a 7 to 10% chance. So now, while we can't really predict earthquakes, it is fairly reasonable and fairly prudent to expect the New Madrid Seismic Zone to probably act somewhat similar in the future as it has acted in the past. USGS has also produced a couple other different types of ways of trying to show this. This is the frequency of damaging earthquakes in a 10,000 year time span. So you can see here they estimate that there's somewhere 200 in the very center of the New Madrid Seismic Zone, 250 damaging earthquakes in a 10,000 year time span. That's a little difficult because obviously we can't go back 10,000 years. And also, I'm not exactly sure what their definition of a damaging earthquake is relative to a 7.0, 6.0, or 5. I'm not sure what they use for this, but it does give you an indication where those earthquakes are across the continent. And being from Minnesota and the Minnesota Geological Society, definitely seems like you guys don't have to worry a huge amount you may feel it, but it doesn't look like you're going to have to worry about a damaging earthquake anytime soon. And here's another one. This is just Mercalli intensities of a kind of gives a Mercalli intensities for the Midwest. And again, if you look at Minnesota there, it shows a Mercalli intensity of about 4 going back. Most of the definition for a 4 on the Mercalli is that you feel the shaking. It feels like a large truck rumbles by, something like that. Typically is the definition of a 4, right in that kind of that span. So a little bit about earthquake predictions and earthquake warnings. We can't predict earthquakes. No one's ever been able to do it. They've tried using a number of different things. Obviously, one of the first things people start looking at is patterns. Parkfield, California had for 88 years had a pattern of an earthquake every 22 years. However, the last time I heard of an earthquake was back in the 70s. So they're pushing close to almost 50 years for an earthquake center near Parkfield, California. So, you know, can't necessarily rely on patterns. We've all heard that, oh, small earthquakes may occur before large earthquakes, but that's never really been proven reliable. Probably the foreshocks that we see if you're trying to predict larger earthquakes related to volcanoes or large magma body movements, that may possibly be the case. However, for something like the Madrid Seismic Zone, foreshocks don't necessarily seem to be something that's reliable. One thing that scientists are looking at are ground tilt or basically strain gauges. So with modern technology, the ability to use lasers and with better and better satellite technology, daily measurements or measurements are much easier to get. So they are able to measure strain much greater. However, we can measure the strain doesn't necessarily give us that threshold of which that fault will rupture based on that strain. Changes in animal behavior. This is the one I always like. Typically, you'll see animals seem to react to earthquakes a little faster. My understanding is they believe that they can possibly feel the primary wave that comes through. It's the first wave that comes through. It's much faster than the other waves. They can feel that primary wave. It's a compressional wave that's much smaller in wave height, but I have seen some videos where the dog gets up and runs about 2 seconds before the earthquake actually hits. And then probably one of the latest things that they've been looking at, and they first noticed this in 1998 in San Francisco, is that prior to the earthquake, there was some radio wave emissions that were abnormal coming from the earth. And I'm not exactly sure how they were detecting these, but I do know that this is kind of one of those areas of earthquake research that they're starting to kind of look into a little more and see if it can be used for some sort of a prediction. And earthquake early warning systems. First and foremost, the New Madrid Seismic Zone is not conducive to an early warning system. The most important thing you have to have with an early warning system is you have to have a pretty good idea or location of your fault itself. It works really well in somewhere like California, places like that, where you know the fault, you know where the fault is, you know where the movement's going to occur, and then you have a series of sensors that set up between that fault and your location. So you can see here, you've got your fault, you've got your municipality, your urban area, you've got these sensors in here. We know that communications are much faster than the waves themselves. So those first sensors measure when the P wave comes through. It sends a signal out to an earthquake alert center, which then sends it out to the community. With early warnings, you're not going to get a huge amount of time. It could be anywhere from just a few seconds to a few minutes. However, there are some pretty protective actions that you can do in those types of situations. Kind of go through some of these from the basic citizens. If you're in a school setting, a minute can basically or definitely help you get school kids underneath their desks. It can get them to drop cover and hold on, climb under their desk. If you're in a situation, you can help warn you to turn off the stove, get those gas that's flowing out of the system or turned off. Safely stop vehicles. For businesses, things automated systems such as elevator doors, open elevator doors so that they're not closed, they're not stuck closed. Production lines shut down. Sensitive equipment can be put into safe mode. Computers, stuff like that. Probably more important, if you can give a surgeon a couple of seconds or a few minutes to know that he needs to stop or he or she needs to stop the surgery, and clip an artery that's important, that may be pretty crucial. And you definitely want to get a dentist to get the drill out of your mouth before he starts shaking around. And one of the things that I thought was really interesting, and it never really occurred to me until I kind of got to thinking about it, but emergency responders. There's a lot of times where the firefighters could be out helping folks. However, a garage door gets stuck shut because there's shifting or something of the building. So an early warning system could automatically open garage doors on emergency personnel or emergency facilities. It also helps personnel prepare and prioritize their response decisions. And then finally, infrastructure, stuff like grid facilities. How do you protect power stations from surges and those types of things? This is about a 6-minute video. It's a little bit long, but it is really interesting. This is out of Japan, I believe, or maybe Korea. But it starts from the outside, and these are several rooms that they have set up on a shake table, and they go from the outside. They'll show it shaking for just about 30 seconds, and then they'll go into each individual room. And I hope this works. Yep. So this is, like I said, it's about a 6-minute video. And I think this represents a 7.4 earthquake or 7.6. I can't remember. So now these are the individual rooms. So thank you. I'll entertain any questions that anybody has. I hope I've kind of shed some light on kind of the New Madrid Seismic Zone, what it is, and the science behind it, and kind of the impacts from it. And I'll be happy to answer any questions.
This is Dave Wilhelm. I'm going to start with a question. Can you describe the Mercalli scale?
So the Mercalli intensity, the Mercalli scale, what it is it is a kind of a measure of damage, where most of us think of an earthquake it'll have a number of magnitude of 5.0, 6.0, or whatever. The Mercalli intensity is a scale that goes from 1 to 12, and with 12 being the highest amount of damage and 1 being the lowest. So for a magnitude, an earthquake has the same magnitude no matter where you're at. If you're a mile away or 100 miles away, you can have the same, an earthquake's magnitude is the same. However, the Mercalli intensity scale, obviously you would expect the most damage to be the highest intensity, to be near the epicenter, and it gets lessens as you move away from the epicenter.
Thanks. This is Dave again. Somebody asked the question, Norm, this is in the chat. Put your questions in Q&A if you can, but here's one in chat. Are the dollar estimates for hurricanes and an earthquake adjusted for inflation equally?
Well, the numbers that I had given you for that HAZIS research was from in 2004. So obviously, if you were trying to adjust that, you know, it was 296 billion, and that was in 2004 dollars, versus Hurricane Harvey, which come in 2016, 2017. I can't remember exactly when it came through. So, I mean, you would expect that 296 billion to probably be a little bit larger, just because it's 15, 16 years old now.
Boot, there's a question that was asked. Are the locations of the Mississippi and Ohio rivers related to the orientation of the New Madrid fault zone?
I do not know the answer to that. If you look at them, it does look like the rivers do follow the rift zones. That's not uncommon. If you think of the Rio Grande follows the Rio Grande Rift. So it is an area. Even if it was an area that dropped down, it's the northern edge of that embayment. So I would suspect at least up through the embayment that it probably does have some impact.
Mm-hmm. Another question, based on those Japanese rooms, how much good would it do for school children to hide under their desks?
Well, one of the things that Missouri's really, and other states as well, has really been doing is, you notice all those bookshelves, that was kind of a worst case scenario. Those bookshelves were not bolted to the walls. Those desks were not bolted to the floor. The copy machines weren't even bolted down. Missouri has gone through with their schools, especially in the New Madrid seismic area, and tried to really encourage these schools to bolt those bookshelves up to the wall so that they don't fall down. And the safest place to be is under a desk. Even if something falls on it, it's still safer than it falling on you.
Okay, we have another one from, let's see, from Mary Helen. Has any paleoarchaeology research been done about the effects of the 1450 AD and 900 AD quakes on the Native American peoples living in the New Madrid area at that time?
I do not know of any, but that doesn't mean that there's not been some of the archaeological studies done. I've not really read anything up on the archaeology of the area at that time.
Okay, and let's see, one from Angie DeLong. Is there any reason to think that the New Madrid earthquakes would have a different structure, PNS waves, than California earthquakes or volcanic earthquakes?
Well, I think the actual waves, the P waves, S waves, and then the surface waves that we see, we can look at earthquakes around the world, and I think the seismic waves that they emit are the same. I think there's places where they're going to react differently. So in the New Madrid Seismic Zone, you have thick alluvial sediments, which allows those waves to amplify versus areas where you have thin sediments and more competent bedrock where they would not necessarily amplify as much. I think the waves will be the same. I think how they interact with the geologic materials is going to be different no matter where it's at on the planet.
Okay, and one from Carol K. Why does the damage extend further according to the Mercalli scale in the New Madrid area and not so far on the West Coast?
So one of the things that if you look at it, you have a more competent portion of your continent in the Midwest. So the energy travels further away, where if you think of California, you're on a leading edge of the continent. Your rocks are much more busted up. They're much more, you don't have the soft sediments and stuff like that. And your rocks are much more busted up. So they can take much more, they can absorb some of that energy. However, when you've got a core of your continent, you have a much more competent rock at depth. That energy travels much further away. So you will feel earthquakes further away because that energy just isn't dampened down.
Okay, let's see, Dave, anything on chat that we should be looking at?
I haven't looked, but there's still 2 more in Q&A that just came in.
Oh, you're right. One from Terry Smith. Would the course of the Mississippi or Ohio rivers likely be changed by a future quake?
I think if you think about it on a small scale, probably you've got lateral spreading is going to push. You're going to push sediment in from one side or the other. The big thing that you always hear about with the 1811 and 1812 is that the Mississippi River ran backwards. That's kind of the big tale that everybody tells. And essentially what happened, if you remember, I showed you that slide with the Chickasaw Bluffs and that one area there that kind of lifted up, and the Reelfoot Lake area that kind of dropped down. You had an uplift of the sediments, which essentially blocked off the Mississippi River. It didn't necessarily flow backwards; it just got dammed up behind that uplift. The uplift was 20 or 30 feet. It's all soft sediment. As soon as that water got up high enough to breach the top of it, it cut through that soft sediment and began to flow back down its path. The actual discussion, Fuller talks about in his 1811 book. The actual discussion was from these folks that were docked along the Mississippi River north of New Madrid. When that got blocked, their boats started moving upstream because that water was backing up behind that blockage. I think from my understanding, it was about 12 or 14 hours until after it actually breached over that blockage and down cut through that.
And let's see, another question from Carol K. New Madrid was a failed rift and has activity, but the failed rift in Minnesota has none, question mark.
I think the failed rift in Minnesota is much older than the I do not know a whole lot about the mid-continent rift in Minnesota. It is much older. If I'm not mistaken, you guys please correct me on this. Isn't it about 1.3 billion years old? where the New Madrid Rift is in about 600 million year range. So I do not know a lot about the mid-continent rift up there, but I do know that it's considerably older.
Yes. Let's see. I'm just
I don't see any more in the chat or in the Q&A. There was a comment from Kenny. Thanks, Boot. Great presentation.
No problem. I'm glad to do it.
So, well, may I say thank you, Boot, for a most enlightening and thought-provoking talk.
Thank you.
I want to thank everybody on for joining us tonight. Hopefully we'll see you in 2 weeks for a brief geological history of Colorado. Thank you all and good night.
Have a good evening. Thank you very much.